I've been using this word conservative to describe some forces we've been working with, but I haven't really talked about what that means and what a non-conservative force would be. Conservative forces offer two-way conversion between kinetic and potential energy. Gravity and the elastic force from a spring are two examples of conservative forces because we can go back and forth trading kinetic and potential energies by changing the body's position. Friction and drag force from the air are two examples of non-conservative forces because they do negative work on the body, regardless of which direction the body moves. As a box slides up a ramp with friction, the friction takes away from the mechanical energy of the system. As the box slides back down, the friction does not then replace what it stole. It takes away again. It works the same way with drag force from a car moving through the air. It experiences drag force decreasing the mechanical energy no matter which way it's going. So where does this mechanical energy that's been stolen from the system go? Does it just cease to exist? No. It gets converted into different forms of energy, usually heat. As the block slides down the ramp, mechanical energy of the block gets transferred to the ramp and heats up the ramp just a little bit. You can test this out yourself if you rub your hands together very fast for a while. Your hands heat up. If you've ever experienced a rug burn from the carpet, you've felt this already. Friction force is a non-conservative force because it causes mechanical energy to not be conserved or retained. But really, if we zoom out and consider that there are more forms of energy than mechanical energy alone, the energy is still conserved within a larger class of energy. Thermal energy exists within a larger class of energy called internal energy. The energy stolen by friction still exists. It's just not mechanical energy anymore. It's internal energy. This leads us to one of the most important concepts in all of physics, the law of conservation of energy, which is written below that diagram. This states that energy is never created or destroyed, it only changes form. This is true always, in all cases. No exception has ever been found. As far as we can tell, it's just how our universe works. The total kinetic energy plus the total potential energy plus the total internal energy is equal to 0. There's no change in total amount of energy, it's just transferred into different forms. This is the law of conservation of energy. I remember when I was a student taking this class and how much this concept of conservation of energy just blew my mind. This class felt to me kind of like a continuous process of getting an upgraded understanding of how the world works. First we had our kinematic equations, which feel kind of wimpy now at this point, but they did a lot of work for us back then. And we got to see how a ball will travel and what the velocity will be at different points after we throw it or shoot it. Then we got Newton's laws, and we started seeing everything around us in terms of the forces acting on stuff. And if you're anything like me for the past few days, since Newton's laws, you've been thinking about everything in terms of the forces that are acting on them, the normal force of your book sitting on the table and everything. Well, now we have upgraded once more, and I bet you'll start to think of things around you in terms of the energies going on. It's a really fun thing to be learning for the first time, and it's really exciting. Next lecture, we move on to momentum, impulse, and collisions, which are also pretty fun.